We are now looking at section 7.4, basic trigonometric equations. Now this is our final topic in trigonometry, and this is how to solve trigonometric equations. So we are going to start with the basic trigonometric equations, and then we will be building to find the more complex trigonometric equations. Okay, here we will learn what type of solutions there are for basic trigs equation, and how do we present them, how do we show them, write them. Okay, so just to start with, often we will have to find all the solutions of trigonometric equation, basic trigonometric equation, or we can be asked to find the solution only in the interval 0 to 2 pi, or some other fixed interval. Now if we look at solutions only in the interval 0 to 2 pi, we call that primary solution. Now for a basic equation like sine of x is equal to a number, or cosine of x is equal to number, these will have two solutions in one complete rotation, or two solutions between 0 to pi, in other words, two primary solutions. From those primary solutions we can write what we call general solution, so which will have infinitely many solutions. So let us look at as an example. So let's say we want to solve this equation that sine of theta is equal to square root of 2 over 2. So what comes to your mind? I believe theta is equal to pi over 4 comes to your mind. Well, is there any? So this is the solution between 0 and 2 pi. Is there any other? Okay, let's see. Now remember, sine is positive in the first quadrant and in the second quadrant. So it means if I have sine of theta is equal to square root of 2 over 2, then one angle is over here and the other angle is terminal ray is over here. So what is this one? This is pi over 4, and the other one, this is 3 pi over 4, 3 pi over 4. So theta is equal to pi over 4 and theta is equal to 3 pi over 4. So these we call primary solutions. So what about if instead of going from in the positive direction of the angle, if we go to the negative, or in other words, if we go to clockwise direction, then what will happen? Well, in the clockwise direction, this will be negative 5 pi over 4, and the other one, this one here, will be negative 7 pi over 4. So what about those? Are these the solution? Let us see. So if I have the graph of the y is equal to sine x, so graph of y is equal to sine x looks like this, and let's say the square root of 2 over 2 is the value over here. So I want to see, if I draw a horizontal line, it crosses the graph of sine in many places, infinitely many places. So what are the value on the x-axis these represent? Those are our solutions. Okay, so now in the interval 0 to 2 pi, so this is the interval 0 to 2 pi, from here till here is 2 pi. If you notice, the graph is crossing the axis, the red line, only in one place, two places, only in two places. What are those? Let's mark them. Let me first clear this thing. Okay, so this is our axis, the black one horizontal. So the red line is up here, so it is crossing the graph in the first complete rotation between 0 to 2 pi. You can see it is only crossing in these two places. So this one is pi over 4, and this one will be the 3 pi over 4. But now it will again cross when? It will cross it over here, which is what? From the x. Now let me take another color and show you. So from 2 pi to this piece, so this distance is pi over 4 again, but from the origin this is 2 pi plus pi over 4. And then in the same way, if you go in the negative direction, you can see it is crossing this piece from negative 2 pi to 0. It is crossing only in two places. So what are those angles? Those are these two angles. Okay. Okay, so now we try to see what other values can we have. So primary solutions should be easy to figure out if you have memorized those table or the unit circle values that I have been mentioning over and over. But let us see what are our values then. So pi over 4 was one of the primary solutions. So related to this one, what are the other solutions we get? So we get pi over 4 plus 2 pi. We will get pi over 4 plus 4 pi, pi over 4 plus 6 pi. So what is this? These are the integer, we call them integer multiples of 2 pi, because 4 pi can be written as 2 times 2 pi. So I can say pi over 4 plus 2 times 2 pi. So okay, let me rewrite it. So this one can be written as pi over 4 plus 0 into 2 pi. This is pi over 4, this one. This one can be written as pi over 4 plus 1 into 2 pi. Then the next one, as I just showed you, is pi over 4 plus 2 into 2 pi. Now this one can be thought of as pi over 4 plus 3 into 2 pi, and so on. So you can see there are infinitely many. So we can say that the solutions are pi over 4 plus k times 2 pi. Okay? So integer multiple of 2 pi. But what about the negative terms? So we noticed that negatives were also there. So how can you get this value? So if you do pi over 4 minus 2 pi, so if we do pi over 4 minus 2 pi, we get minus 7 over 7 pi over 4. If you do pi over 4 minus 4 pi, you get negative 15 pi over 4, and so on. So these are also going to be the solution. So which means general solution is like this, where k is equal to 0, plus minus 1, plus minus 2, and so on. So now instead of writing them in this form, it takes up more time. So we write it collectively as pi over 4 plus 2k pi. So normally we write it instead of k2 pi, 2k pi or 2 pi k. Now what about the other solutions? Well, if you recall, there was another one, primary solution, which was 3 pi over 4. So what are the general solutions for with this one? Just 3 pi over 4 plus 2k pi, same thing. So for the sine, the basic equation of sine of x or sine of theta or sine of t or whatever the variable is, equal to a number. So find the primary solutions. Then for the general solution, just write the one primary solution plus 2k pi, and k can have the values 0, plus minus 1, plus minus. Don't forget to mention that. So that is your general solution. Often in the question, it will ask you to give like 4 solutions, 4 general solutions or something. So you can then evaluate the solution and find out whatever is required. Anyhow, so this is how we look at the general solutions. Okay, so here is what we were talking about. Theta is equal to pi over 4 and 3 pi over 4. These are our primary solutions, and the general solutions will be theta is equal to pi over 4 plus 2k pi, and theta is equal to 3 pi over 4 plus 2k pi, where k is 0, plus minus 1, plus minus 2, and so on. So if, as I was just saying, if we have to give 6 solutions, we can pick values of k of our choice and find the solution. For example, for k is equal to -1, 0, 1, we get, so plug in these values in the first general solution, and then plug in the second general solution, we end up getting 6 values. So some are negative, some are positive, so a good mix. Well, could we have done, instead of -1, 0, 1, could we have taken k is equal to 1, 2, 3? Yes, you can do that. But remember, you have to do it with both thetas, because otherwise if you do it with only one of them, then you will end up only getting 3 solutions. Okay, so these ones that we get from the general solutions, we call them particular solutions. So here the first example says, solve the given equation, give the general solution, then give 6 particular solutions. Okay, it's not asking for the primary solutions, okay, but we have to find primary. That's how we start. So this is saying cosine of theta is negative square root of 3 over 2. So what does that mean? It means the angle is going to be in the second quadrant or in the third quadrant. And what is the angle? Well, this is cosine, so it means this angle is pi over 6, which means this one is 5 pi over 6. And then the next one will be 7 pi over 6. So we have theta is equal to 5 pi over 6 and theta is equal to 7 pi over 6. So these are our primary solutions, because they are in the interval 0 to 2 pi. So now general solution, 5 pi over 6 plus 2k pi, and theta is equal to 7 pi over 6 plus 2k pi, and k is equal to 0, plus minus 1, plus minus 2, plus minus 3, and so on. This is general solution. And now we have to give 6 values. So again, as we did before, we can say let k equal to negative 1, 0, 1. So we get theta equals, so from the first one I get negative 5 pi over 6 minus 2 pi, which is going to be negative 7 pi over 6. When I plug in 0, I will get 5 pi over 6. And when I plug in 1, I'll get 5 pi over 6 plus 2 pi, which means 12 plus 5 is 17 pi over 6. And now I will plug in negative 1 for the theta, for the second primary solution. So I get negative 7 pi over 6 minus 2 pi, which will give me negative 5 pi over 6. And then 0 will give me 7 pi over 6. And then 1 will give me 19 pi over 6. So these are our 6 particular solutions. Okay, and here is another example. Now this is for tangent of theta. So now it says tangent of theta is equal to square root of 3. Okay, so we have to go back now and think which angle has this situation. So if you recall, sine of pi over 3 is square root of 3 over 2. Cosine of pi over 3 is 1 over 2. So tangent of pi over 3 will be square root of 3 over 2 over 1 over 2, which is square root of 3. Okay, so the theta is primary solutions, and you can make the diagram here. Because theta is positive, it will be in this quadrant or in this quadrant. So maybe pi over 3, so this will be 4 pi over 3. So we will say theta equals pi over 3 and theta equals 4 pi over 3. But actually, in this case, you will notice I don't need to have both of these. Why? So instead of now saying our general solution, theta is equal to pi over 3 plus 2k pi. Remember, the period of pi is tangent is pi, not 2 pi. So it repeats after every pi units. So which means we can actually reduce the number of primary solutions. So I can just say the primary solution is only pi over 6. How can I get this one from that? Well, pi over 6 plus pi. So this much is pi. So I can say that general solution will be pi over 3 plus k pi, where k is equal to, again, 0 plus minus 1 plus minus 2, so on. So for 6 solution now, you will have to actually pick 6 values. So it's your choice which one you want to pick. Maybe some negative, some positive. So for k is equal to negative 2, negative 1, 0, 1, 2. Well, these are 5, so we have to go one more. Well, we can go in this positive direction or we can go in the negative direction. Okay, so what are those? So theta will be equal to pi over 3 minus 2 pi. For k, we will plug in negative 2. So pi over 3 minus 2 pi will give me what? Negative 5 pi over 3. Then pi over 3 minus pi will give me negative 2 pi over 3, and then 0 will give us just pi over 3, and then pi over 3 plus 1 will give us 4 pi over 3, and then pi over 3 plus 2 will give us 7 pi over 3, and then pi over 3 plus 3 pi will give us 10 pi over 3. So we have the 6 particular solutions. So here, this is what I just said, that in the case of theta, tangent, the primary, the basic equation, trig equation for tangent, we only do the primary solution plus k pi, not 2k pi, because the period of theta is tangent is pi. Okay, let's do a little bit complicated, not too complicated still. Okay, so what is this? How do we do that? If you notice here, the trig function that appears in the first one is cosine x, which means it is still a basic equation, but it is not written in the form that we saw previously. So what do? We isolate the trig function. So I can write it like, maybe I'll just go down here. Square root of 2 cosine of x is equal to 1. So cosine of x is equal to 1 over square root of 2, which when rationalized to give me square root of 2 over 2. So what are the primary solution here? So it's saying find all solutions. Okay, so now we are not going to find those particular ones. We are just going to find the basic and then write the primary. Okay, so this one is saying so primary solutions. So we know that this cosine is positive in this quadrant and in this quadrant. So this will be at pi over 4. So can I say this is negative pi over 4? Well, yes, this will be one of the answer, but that is not a primary solution. Okay, and we actually, as I said, we don't even need. Do we need the second or no? Yes, we do. This is cosine x, not tangent x. So we are not going to pick one, but we have to have two. So the second one will be, so this is pi over 4. The second one will be, go like this. That will be 7 pi over 4. So we say x is equal to pi over 4 and then 7 pi over 4. So these are your primary solution. So general solution, pi over 4 plus 2k pi, 7 pi over 4 plus 2k pi. K equals 0 plus minus 1 plus minus 2 dot dot dot. So put 3 dots. So that is your answer. Looking at the next equation, so again this is a trigonometric function, cotangent x. So we have to separate cotangent x. So we can say square root of 3 cotangent x equals negative 1. So cotangent x is equal to negative 1 over square root of 3. So from here, I mean, we are more familiar with sine, cosine and tangent, so I would like to convert it into a tangent equation. So tangent of x will be equal to negative square root of 3. Now, if you recall, tangent of x is equal to square root of 3 happens when x is pi over 3. So for the negative one, what will happen now? So angle will be in the second quadrant or in the fourth quadrant, because these are the two where the tangent is negative. So this angle will be 2 pi over 3 and this will be 5 pi over 3. So our primary solutions are x is equal to 2 pi over 3 and x is equal to 5 pi over 3. So general solution just take these two. So again, now should we take 2? No, we don't need to, right? So it will be 2 pi over 3 plus k pi. K is equal to 0 plus minus 1 plus minus 2 dot dot dot. Okay, looking at the next equation. So this is saying cotangent of, okay, let me move this one over from here and put it. The next is 4 cosine square x minus 3 is equal to 0. So I isolate the trig expression or trig function. So I get 4 cosine square x equals 3. So cosine square x will be equal to 3 over 4. So cosine x will be equal to, now this is again a very important thing, plus minus square root of 3 over 4, which gives me plus minus square root of 3 over square root of 4 or square root of 3 over 2. So now we have two equations. Okay, so this is cosine of x equals square root of 3 over 2, and the other equation is cosine of x equals negative square root of 3 over 2. So that from here the primary solutions will be x equals, so this happens when x is pi over 6. So pi over 6 is cosine positive, so it will, the next angle will be in the fourth quadrant, which is 11 pi over 6. So these are your primary, and for the second equation the primary will be, so this is cosine x is equal to negative square root of 3 over 2. We are in the second quadrant and the third quadrant. So in the second quadrant this happens when you have x is equal to 5 pi over 6, and then when x is equal to 7 pi over 6. So this now general solution will be, now you will have 4 equations. But just let's check what is happening here. Can we reduce them? Can we reduce them to 2? So note here, pi over 6 is here, 11 pi over 6 is over here, 5 pi over 6 is here, and 7 pi over 6 will be here. So again this is giving us the situation of the tangent, right? So instead of now saying pi over 6 plus 2k pi, 11 pi over 6 plus 2k pi, 5 pi over 6 plus 2k pi, 7 pi over 6 plus 2k pi, we will be writing redundant. We will be writing many of these values twice. So we can do pi over 6 plus k pi, and then 7 pi over 6 or 11 pi over 6. Yeah, 11 pi over 6. So stay with the one of them. So if I took the pi over 6, then the other one should be 11 pi over 6. Or if you do not understand this, it's okay to write those 4 general solutions with each of them. So these are the 4 primary solutions, so you can write plus 2k pi with each of them and you get our general solution. In the same way over here, next example 4, we have that cosecant square x will be equal to 4. So cosecant x will be equal to plus minus 2. What does that mean? It means sine x will be equal to plus minus 1/2. So 2 equations again. So sine of x is equal to 1/2. The other equation is sine of x is equal to negative 1/2. So this will give me the primary solution will be x is equal to pi over 6 and 5 pi over 6. The second one will say x is equal to 7 pi over 6 and 11 pi over 6. And then you should be able to write the general solution. Okay, so here are a little bit more complicated ones. Now remember these complicated ones are not like out of this world. They involve little algebra that you have learned before. So if you notice here, this is an equation which we can say is of quadratic form. So if you can do the substitution, so let u is equal to sine theta, then what happens? This becomes 2u square minus u minus 1 is equal to 0. So what does that mean? You can solve it by factoring. So you get 2u. Okay, so because this is negative sign, so I should have negative 1 and then I have positive 1 over here. So which is equal to 0, which gives me u is equal to 1 or u is equal to negative 1/2. So from the first one I get u is equal to negative 1/2, and from this one I get u is equal to 1. So I have 2 equations. So this one gives us sine of theta equal to negative 1/2, which implies theta is equal to 7 pi over 6 or theta is equal to 11 pi over 6. So these are the primary. Now this one didn't mention which type of solutions. We will just go to do with the primary. And the other equation u is equal to 1, which implies sine of theta is equal to 1. Now when is sine theta 1? When theta is pi over 2. So these are again the primary. So this gives us only one solution. Looking at the next example, this is also quadratic form. So let u equals, now you can do the substitution, or if you can do it without substitution, directly from here factor, thinking of this as like x square or u square So you have cosine of theta. Okay. So minus, one of them will be minus 2, the other one will be plus 1. Doesn't matter which one is. So from here you get cosine, so this is equal to 0. So we get cosine of theta minus 2 is equal to 0, or cosine of theta plus 1 equal to 0. So the first one gives me cosine of theta is equal to 2, and the second gives me cosine of theta equal to negative 1. Now this has no solution because we are getting cosine of theta is equal to 2, which is bigger than 1. Remember, the cosine has to stay within the interval negative 1 to 1. This one gives me only one solution, which is theta is equal to pi. So this is again the primary solution. Now if we are looking at the general solution, this will become pi plus 2k pi . Looking at the next one, again this is a quadratic, so again so equation becomes 2u square plus 5u minus 12 is equal to 0. What are the factors? Okay. So we are getting 2u plus 5u minus 12. So what should be the factors? 12 times 2 is 24. So we are looking for factors of 24 which add up to a plus, actually negative 24, which add up to a plus 5. So if you look at negative 6 and 4, no. Negative 12 and 2, no. Negative 3 and 4. No, sorry, 3 and 8. Yeah, that works. Negative 3 and 8. So 2u so if I put this should work, is equal to 0. So 2u plus 8 is equal to 0, or u. But this is giving negative 4, this gives me u is equal to 3. But we were like sine of theta equal to negative 4 and sine of theta is equal to 3, so no solution. Okay, so this is how we solve these trig equations. So if you know the basic trig values, or the values on the unit circle, and you know your algebra, then this is all needed for the trig equation. Okay, then we will go to section 7.5, which is the last section, and which involves again solving equations, but a little more difficult ones.